Hey everyone, welcome back to the channel. Today we are doing a complete Apache Kafka interview deep dive. Kafka shows up in almost every backend and system design interview. And in this video, we'll cover the 9 topics that interviewers love the most: architecture, partitioning, consumer groups, replication, delivery semantics, retention, ordering guarantees, schema evolution, and finally, when you should and should not use Kafka. Each topic comes straight from real interview questions, and for every single one, I'll give you a simple mental model, the key technical details, and the trade-offs interviewers want to hear. By the end of this video, you'll be able to answer Kafka questions with confidence. Let's dive in. Topic 1: Architecture. Here is the single most important idea in this whole video. Kafka is not a traditional message queue. It is a distributed, append-only log. Producers append records to the end of the log, and consumers read forward at their own pace by tracking a position called an offset. Messages are not deleted when they are read, and that changes everything. Because messages stick around, many independent consumers can replay the same data, and a slow consumer never blocks a fast one. The best analogy is a newspaper archive. Every edition is filed in order and never thrown away. Any number of readers can start from any past date and read forward at their own speed, and one slow reader doesn't stop anyone else. Structurally, a Kafka cluster is a set of servers called brokers. Data is organized into topics, and every topic is split into partitions. The partition is the unit of parallelism and ordering, and each one is an ordered, immutable sequence of records stored on disk. Historically, Zookeeper managed cluster metadata, but modern Kafka uses care-aft mode, which folds that role into the brokers themselves. And the design is built for speed, sequential disk writes, zero-copy transfers, batching, and compression let a single cluster handle millions of messages per second. Topic 2: Producers and Partitioning. When a producer sends a record, Kafka has to decide which partition of the topic it goes to, and this choice really matters for 2 reasons. First, ordering is guaranteed only within a partition, and second, an even partition assignment creates hot spots that overload individual brokers. So how does Kafka choose? If the record has a key, Kafka hashes that key and maps it to a partition. That means all records with the same key always land in the same partition, and are therefore strictly ordered relative to each other. If there is no key, the producer just spreads records across partitions for even load. It's like a post office sorting letters into numbered bins by postcode. Every letter for the same postcode goes into the same bin, in arrival order, while different postcodes fill different bins in parallel. 2 more things interviewers expect you to mention. Producers batch records, compress them, and send asynchronously for throughput. And there are 2 critical settings. The ACK setting controls the trade-off between durability and latency, and enabling idempotence prevents duplicate messages caused by retries. In production, you almost always want idempotence turned on. Topic 3: Consumer groups and rebalancing. This is how Kafka scales consumption. Consumers join a consumer group identified by a group ID. Kafka assigns each partition of a subscribed topic to exactly one consumer in the group, so the group as a whole processes every partition in parallel without any double processing. And different groups are completely independent. Each one receives the full stream. Picture a team of cashiers splitting the checkout lanes of one store. Each lane is staffed by exactly one cashier. That's one consumer group. A second, separate team auditing the same lanes is a different group, and it sees every transaction independently. Now here's the classic interview gotcha. The practical ceiling on parallelism is the partition count. If a topic has 6 partitions, at most 6 consumers in a group do useful work. Any extra consumers just sit idle. When members join, leave, or crash, the group coordinator triggers a rebalance to redistribute partitions. Older Kafka versions used a stop the world approach, where everyone paused. Modern Kafka uses cooperative, incremental rebalancing to avoid that pause. And to track progress, consumers commit offsets, either automatically or manually, so a restarted consumer resumes exactly where the group left off. Topic 4: Replication and durability. How does Kafka survive a broker failure without losing data? Each partition is replicated across several brokers, controlled by the replication factor. One replica is the leader, and it serves all reads and writes. The rest are followers that continuously fetch from the leader. The set of replicas that are fully caught up is called the in-sync replica set, or ISR. Think of the document signed in triplicate and kept in 3 different offices. A change only becomes official once at least 2 offices hold the updated copy, so losing one office never loses the record. In Kafka terms, with access set to all, a write is committed once every member of the ISR has it. If the leader fails, the controller promotes an in-sync follower and no acknowledged data is lost. The min in-sync replica setting defines how many replicas must acknowledge a write, combined with AXA all, that is Kafka's core durability guarantee. And of course, there's a deliberate trade-off here, and mentioning it will earn you points in an interview. Requiring more in-sync replicas increases durability, but it reduces availability for writes if replicas fall behind or go offline. Durability and availability pull in opposite directions, and your job as an engineer is to pick the right balance for the workload. Topic 5. Delivery semantics. This is one of the most common interview questions in all messaging. Every messaging system delivers under one of 3 guarantees. At most once means messages may be lost, but never duplicated. You commit the offset before processing. At least once means messages are never lost, but may be redelivered. You process first, then commit. That's the most common default. And exactly once means each message affects the result exactly one time. No loss, and no duplicates. Here's how to remember the difference. At least once is mailing a letter with delivery confirmation. It always arrives, but if the confirmation gets lost, you might send it again. Exactly once is a bank transfer with a transaction ID that the bank uses to ignore any duplicate submission. Same meant twice, but the money only moves once. So how does Kafka actually achieve exactly once? 2 mechanisms working together. First, the idempotent producer, which deduplicates retries using a producer ID and sequence numbers. Second, transactions, which atomically write to multiple partitions and commit consumer offsets in the same transaction. On the consuming side, you set isolation level to read committed, so aborted records are skipped. But here's the nuance that separates senior candidates. Kafka's transactions do not extend into your database. For true end-to-end exactly once with an external system, you still need idempotent writes or the outbox pattern. Topic 6. Log retention and compaction. Remember, Kafka keeps messages regardless of whether they've been consumed. The retention policy decides when they age out. With time or size-based retention, Kafka deletes whole log segments once they exceed the configured age or size. That's ideal for event streams where old events simply stop mattering, like a security camera that overwrites footage older than 30 days. Log compaction is completely different. Instead of deleting by age, it guarantees the latest value for each key is always retained, while older values for the same key are eventually garbage collected. Think of an address book. You keep each person's current phone number and discard the old ones, but you keep every person forever. This turns a topic into a durable, replayable changelog of current state per key, and it's the basis of Kafka Stream state stores in the consumer offsets topic. 2 details worth knowing: a topic can combine compaction with a time for, and a delete is represented by a tombstone, a record with a null value, which compaction eventually removes. Topic 7. Ordering guarantees. Say this sentence in your interview and you're already ahead. Kafka guarantees ordering only within a single partition. Records appended to one partition are read back in exactly that order, identified by their offsets. But across partitions, there is no global ordering because partitions are consumed in parallel by independent consumers. Back to our supermarket, several checkout lanes, each processing its own customer strictly in line, but no single order across lanes. Put one family in one lane, and that family is always served in order. That's your partition key. Routing all events for one entity, say one order ID, to the same partition is the standard way to preserve per entity order. The trade-off: ordering and parallelism pull in opposite directions. A single partition is perfectly ordered, but it caps your throughput at one consumer. And here's a subtle pitfall that makes for a great interview answer. with retries enabled and more than one in-flight request per connection. A failed then retried batch can land after a later batch, silently reordering records inside a partition. The fix is the idempotent producer, and it's the recommended setting whenever order matters. Topic 8. Schema Registry and Evolution. In a long-lived event stream, producers and consumers are deployed at different times and evolve separately. If a producer changes the message format, old consumers can break. A schema registry solves this by storing version schemas, Avro, Protobuf, or JSON schema, in one central place and enforcing compatibility rules. It's like a shared API contract and version control, with a linter that blocks any change that would break existing callers. Mechanically, messages carry a small schema ID instead of the full schema, so payloads stay compact, and consumers fetch and cache the schema by ID to deserialize. The registry enforces a compatibility mode: backward, where new consumers can read old data; forward, where old consumers can read new data; or full, which is both. A producer that tries to register an incompatible schema is simply rejected. The result: format errors shift from runtime failures in production to deploy time validation. And that is the whole point. Our final topic: when should you actually use Kafka? Kafka shines as a high throughput, durable event streaming platform where data is read by many independent consumers, where replaying history matters, and where you want to retain events as a source of truth. Millions of messages per second, horizontal scale through partitions, and long retention, those are its signature strengths. The analogy I love: Kafka is a freight rail network, enormous, sustained throughput along fixed lines, unbeatable at volume, but it's overkill and clumsy for delivering a single parcel across town, where a courier, a simple queue, is the right tool. Kafka is a perfect when you need classic broker features, complex routing, per message priority, per message TTL, or per message acknowledgement with delayed redelivery. And it's heavier to operate than a managed queue. For simple point-to-point work at modest volume, SQS for RabbitMQ is simpler and cheaper. So the decision usually comes down to one question: do you have a stream consumed in many ways with replay needs? That's Kafka. Or do you have discrete tasks and commands handed to workers? That's a queue. Keep that one-liner ready. It's the perfect closing sentence for this interview answer. And that's the complete Apache Kafka interview deep dive. We covered architecture, partitioning, consumer groups, replication, delivery semantics, retention and compaction, ordering, schema evolution, and when to use Kafka. If this helped you, hit like and subscribe. Next up in the series, we're covering RabbitMQ and Amazon SQS. And for the full question bank with diagrams and mock interviews, head over to prepforge.net. Good luck with your interview. You've got this.